Today we will talk about the independent source. Actually, we will deal with about the source. What is source in the electric circuit? Source is a voltage or current generator capable for the supplying energy to the circuit. So the way to supply the energy, they have two types. The first thing is voltage source, and second thing is current source. The among sources that will be to supply the voltage or current, the independence means the voltage or the current is generated not depending on the other circuit variables. That means this, the voltage and current is supplied some values or some waveform not dependent on the other the circuit variables. So the voltage source and current source supply the voltage V or the current. The symbol of voltage source looks like this. So I can draw again. So we make one circles, then make the polarity of the voltages this way and here. Then we express the value of the voltages Vt. It could be the function of time or it could be constant, not dependent on time. But the important thing is that value does not affected by the other variables in the other circuit. And we can define the direction of current. When you define the current direction is IT, then you can say this is a, what is that? This is a passive convention. And we can draw, we can decide the direction of current in this way. Then you can say this circuit is the written is the active convention. Okay. In current source case, we use on the circle in the same way with the voltage source, and instead of the polarity, we draw the arrow in a circle. So we can like here, we can write in the direction of the arrow, then we write here for T. Then we say this is a current source, especially this is independent, the current source. And we can write the voltage direction, the polarity of the voltage here, this way. Then this is active convention. And if we use the direction of that in this way, then this is passive convention. Anyway, the important thing is voltage source and current source is the value of the voltage or current value does not depended by on other circuit variables. And you use the symbol is circle, and the case of voltage is plus minus. In case of the current is an arrow in this way. Especially in the case of voltage source, these element generate the voltage Vt. Then the current, how much current follow in this element. The color value is not determined by the symbol. The current is determined by other element. I will give you some example. Okay, we make a source in this way, and we can say this is defined at 5 volts here. Then I don't know how much follow this current, but I will denote the current is IT in this way. Then the current is not determined by this source. The current is determined by the other circuits, because this is the voltage source. The voltage source determines only the voltage values. And if the other circuit consists of the only one resistor, maybe 5 ohm, then the current IT will be by the Ohm's law 5 so 1 amp. Then that value is 1 amp. So in this circuit, the voltage is determined by this source because this is the voltage source. But current flowing through this voltage source does not determined by that values. It is determined by that values and other circuits. So voltage source determines the only voltage, not the current. For example, we use the same voltage source, but we adding the 5 ohm, so 1 ohm, then current IT is 5 amp. We use the same voltage source, but current is not different. The current is different, so this is 5 amps. In this case, 1 amp. This is a 5 amp. That means voltage source determine the only voltage values. So dependent source, independent source is a voltage or current generator, not depending on the other circuit variables. For example, we can say battery. Battery is a very fundamental example of the voltage source. It's like VT is 5 volts, 9 volts. That means the voltage of battery is 9 volts. In this case, the current of battery is not known and depends on the circuit. And we can like voltage batteries in this way. And in other book, the symbol of voltage source is like in this way, or in this way. This is plus and minus. This is plus and minus. In the case of a current source, we can write the current source in this way. IT is minus 0.25. This is, and it is amps. That means the current is fixed as minus 0.25 amps. Then the same way, the voltage depends on the circuit. Then how to think about that? If, for example, was VT is 25 volts. Is this the dependent source or not? Actually, this is a independent source. Why? Because Vt is determined only value of t, not the other variable of the circuit. So we can say this is a independent source. A voltage, we need to think about the ideal voltage source. What is the voltage source, ideal voltage source? The voltage of ideal voltage source is given in the special function of the Vt. And in this case, the current is determined by the rest of the circuit. I also give you some example of that. So we can draw the voltage like that. Then we make it this way. So we can define the voltage as the voltage value is 10 volts here. Then we define the current in this way, IT, but I don't know what is value of IT. This voltage source define only voltage values 10 volts. Then who determine the current flowing through the voltage source? There is a other circuit. Here. If the value is 10 ohm, then IT would be 10 by 10 is 1 amp. It is the same voltage source, 10 volts. Then it's connected with other values. For example, 1 amp. Then the current flowing through the source, IT. Then IT will be 10 amps. That means voltage source only define the given function of voltage. Then current is determined by the other rest of the circuit. So in the case of the current source, the current of the ideal current source is given to the special function of IT. Then the voltage is determined the rest of the circuit. The same way, I can give you a big example. Like we can assume that this is a current source. The value is 10 amp. Then I don't know how much of the voltage is here is Vt. And if this is connected the electric circuit in this way, for example, this is 10 ohm, then Vt is Ri, because current flowing from here to there is 10 amp, because this is current source. So it is 10 and 10 is 100 volts. So in this case, that value is 100 volts. And with the same current source, this is 10 amps, then they connect the other circuit. For example, this is 1 amp, 1 ohm. Then current following through this path is a 10 amp. So the voltage Vt is Ri, R is 1 and I is 10 amps, so 10 volt. So in this case, the VT is 10 volt. So they have the same current source, 10 amps current source, but voltage is different. They're taken in the two terminals. Why? The current source supply the given the current, so the voltage is determined by the other circuit in this way. So we need to think about the ideal voltage source and real voltage source. Actually, this is very important because we in textbook we think about the voltage source is ideal, but because we are engineer, we need to deal with the real voltage source. Then real voltage source has some different characteristic to compare the ideal voltage source when it covered in the textbook. So we need to know about what is a real and the ideal. The most common characteristic of the real voltage source is the leakage impedance. There's a actually, you don't know what is the impedance. Impedance will be covered in the circuit theory second. Then may be covered in the next semester, the circuit theory second. But anyway, in this time, we think the impedance is kind of a resistor. When leakage means a kind of in Korean is 기생성분. Does not consider in the ideal normal model, but in some case the leakage is placed in the real voltage. When you draw the ideal voltage source like in this way here, so this is voltage, so we draw this is a V is a VT, then this is we can define this is VOT, and the real voltage source, the voltage, the same voltage source, the VT, but there are some resistor in here, so this is a VOT. There's some leakage. If that value is 0, then the real model and the ideal model is same, but there will be very small values, 0.001 ohm. It's very small values, but there are some register values in the real voltage source. We call that this is a leakage resistor, leakage impedance. In this case, this is a real output voltage is the same with the designed voltage value. For example, we use 9-volt battery. In ideal case, this is 9 volts. Then the terminal voltage of T is 9. It does not depending on the other circuits. This is always 9 volts. But in real case, if we use in real case, this is 9 volts. When you assume that value is 0.001 ohm with very small values. But when it is open, that means no load and no resistor, then this is how much is this I? I is 0. Then the VRT, this is the voltage value we can measure in the terminal of the battery. Then VRT is 9 minus R leakage multiplied by current. So, and what is current? Current is 9 divided by the R leakage plus R load. We say this is RL. So if R is infinite, then I is 0, then VOT will be 9 volts. In this case, this value is the same with the ideal voltage values. But if RL, the value is, for example, for each calculation, ohm, then I is 9 is 1 amps. Then VOT is how much is it? 9 minus 0.001 multiplied 1 is then means this is not 9 volts. This is smaller than the 9 volt. Why? Because of this leakage impedance. So in real battery voltage is dropped caused by leakage impedance in this way. As small as the value of leakage impedance, then the voltage source is like an ideal voltage source. And other characteristic of the voltage source, ideal source and real source is temperature. The second characteristic is temperature. And actually, we does not consider in the circuit theory. We does not consider about the effect of the temperature, but in real voltage source, the temperature is very important. The characteristic of to define the function of the voltage. And third thing is chemical characteristic. Anyway, the important thing is the effect of temperature or chemical temperature can be modeled through the leakage input impedance. This is very important. If we use the good battery, that means that value is very small. If we use bad battery, that means leakage value is higher than the battery is. And we will talk about what is a source circuit and the open circuit. The source circuit and open circuit is a special case of the ideal sources. What is the meaning of a source circuit? A source circuit. And what is the open circuit? Short means the circuit is connected without any resistance. That means the potential of that point and that point is same. Then you can use this as one line. That means in between 2 points does not have any potential difference. So this is connected in the same potential in 2 points. And you can say this is a short. And open means this point and this point. You cannot. The current cannot flow this way. So this is different potential. I don't know what is that, but anyway, that point, the potential would be different. Then current cannot follow this way. So in the short case, because potentially is the same, that means the VT of that is 0. So short case, the ideal voltage source having the voltage is 0. And open circuit means because this is not connected to the point. That means current cannot flow this point. So in this case, current is 0. So this is a short, and this is open. The short circuit and open circuit can describe any other viewpoint of the register. So when you say the short circuit is when you say this is a point and this point, this is a short circuit, that means R is 0. Because R is 0, even though if they follow some current I, then what is the voltage difference to point? V is Ri, because R is 0. So I don't know how much it follows through the current. It's always 0. So we can say this is a short circuit. And open circuit, the current I is 0. Because of that, the current cannot flow this point. Then when the current is 0, this is the V, and V is IR, then means I is V over R. So I don't know what is the value of V, but if R is infinity, then current is always 0. So in this case, R is modeled as infinite resistor. So this is the open circuit and this is the short circuit. Next, we will think about the dependent source. You need to figure out the dependent, not independent. What is dependent? Dependent means the value is affected by the other values. The voltage or current of one circuit element is proportional to the voltage or current of two second circuit element. What is that? This is an example of the dependent source. It could be a voltage source or it could be a current source. The symbol of the dependent source is like that. This way. And in the case of the dependent voltage source, we define the direction this way. And we mean write Vt. And the important thing is Vt is not constant value or the time varying values. The Vt is determined by the other value of the current or function. Vi. And the same way, the current dependent source is in this symbol and the arrow in here. This is IT. The same way, the current value defined in this symbol is dependent on the value of V and I in the other circuit. I will give you some example. So this is what is value? Because symbol is plus minus, then this is dependent the voltage source. So but the value of the terminal's value voltage is determined by 5 amps, means the current following in here this resistor. I don't know what value of the current of that, but that value determines the voltage here. This is a dependent voltage source. The voltage value generated by the source is determined by the current following through this resistor. This is a dependent voltage source. So we can think about that. We define this as the I here. And this is another example of that. This is a current source because this is arrow current source. But the value of the current generated by the source is determined by the voltage values of the voltage of this resistor. Define this is the V here. So the current flowing through this dependent current source is determined by that values. Then you can say this is a dependent current source. There are four kind of the dependent source. The first thing is the current control the voltage source. That is that. I don't know what is of the value, but the source is a type of the voltage source. This source generates define the voltage values VD, but that value is determined by the current flowing the other element in the circuit, like IC. Then I don't know what's the value of that, but the value will define the other component. But anyway, the voltage generated by this source is determined by the current. So current control the voltage source. So in this case, you can say I don't know what value of the IC, but the VD is determined by the IC and the gain of R. Then you can say R, the gain, is divided by IC. The dimension of voltage is V and dimension of current is amps. So this is dimension of that is ohm. So we say this is a gain of current controlled the voltage source. And unit of that is V divided by A. The dependent source is the voltage controlled in the voltage source. Let's say CVC and VCVS. Because this is a voltage source, so that is a symbol that way, because voltage source is plus minus then. This voltage source supply the voltage VD, and the value of VD is determined by other voltage values in the circuit VC, and some proportional gain will be. So VD is other control values VC and is B. You can say the B is gain of VC VS. So B is VD divided by VC. This is voltage divided by voltage. The third thing is the current source, but the current value is controlled by the voltage of other element. So we can draw the symbol in this way here. Then this source supply the current ID, but the value of ID is determined by the voltage of other element is VC. So in the ID is GVC. So G is the gain of voltage controlled current source. And G is ID divided by VC. Dimension of that is ampere divided by voltage. Another source is a current control and current source. because this is current source, so current is supplied by this source. But how much the current flowing through the source, that is determined by the current flowing through other circuit. So ID is determined by other current. This is a gain of that. Let's say this is a gain of the current controlled the current source. That is ampere divided by. Dependent source is very useful the way to model the electronic device like a transistor. So we can say what is a real example of dependent source? In the ideal, the voltage source is a real example of the battery. But so this is very easy to imagine what is a voltage source, independent voltage source. But what is the real example of dependent source? That is very useful to model the electronic device like MOSFET and the BJT, bipolar junction transistor. Maybe this element is covered in maybe the electronic circuits and maybe covered in next semester. This is a symbol of bipolar BJT, bipolar junction transistor. They have three terminals, A and C, B, A is emitter and collector, and is the base. Then this model can be used, this model like that. What is that? And through the current, you're following this way. This is IC. IC is determined by VB. What is VB? The value between here. VB. So the current flowing through this way, IC, is determined by voltage or between the B and E, VBE. The gain is GM. So this can be replaced in this model. So if we draw this way here, then that will be replaced here. Then I don't know what's the value of the current, but characteristic of this the BJT. So the current flowing based on this VB. So based on that values, the current is determined. Then because of current, the basis RC, the output voltage is determined by that. So if we inject some VB here, then our VO can be calculated. So what is VO? VO is minus RC GM VBE. That means VB is amplified by this gain of VO. So this is a very simple amplifier. So this is a simple example of the dependent source. So we can solve the problems. So determine the power observed by VC and VS in voltage controlling voltage source. That means this is a voltage source here. So we need to calculate. This is a voltage meter. It means in voltage meter, the between 2 point is open. So this is open. So that means there's a very infinite the resistor. So the current flowing resistor is 0. So in the case of ampere meter, this is a short circuit. So current flowing in this way, no voltage. In this case, there is 0 voltage difference. That is the characteristic of ampere meter, and this is the characteristic of the voltage meter. Voltage meter only measure the voltage. So it does not. This is because this is measurement unit. The voltage meter and ampere meter. this should not doesn't they does not have any effect on the circuit. So I will give you some simple example of that. So if you want to some measure the voltage like here, this is 10 volts, then this is 10 ohm. Then we want to measure the voltage between here and here. So we adding some devices. Here, this is a voltmeter. This is not element to generate any power in the circuit. This is a measurement unit, so it does not affect the current distribution or voltage distribution through this circuit. This is just only for the measurement. Then without that values, without the measurement, I mean the current flow should be 0. So that means that measurement value is infinite resistor. Then if we measure the current, so this R, then some unit can be connected through this way. It's current, this is a current meter or amp meter. This unit just measure the current, does not affect any into the circuit. That means that the impedance R is 0. So this measurement unit does not give any effect in the circuit. So we can measure, I mean, you don't need to do about what is the value of that. So we need to think about the circuit is more simple. Like there is 12 volt here, and resistor 2 ohm, and this is the current source 0.5 amps, and there are different voltages VD to VC, and the impedance is 4 ohm. Connecting to the way. Then this ampere meter gives some hint of the current. I is 1.5 amps, 1.5 amps. And this measurement, the voltmeter, gave us some hint. What's the value of that? Is we define the VC, which is 2 volt. Then we need to know about the power observed by this source. Now what is power? Power is voltage and current. So because of the definition of the dependent source, the VD is 2 VC. The VC is a hint, the 2 volt. That means this is how much is it? VD is 4 volt. And current flowing this dependent source is 1.5 amps. In the direction of current is defined to going to the positive terminal. That means this is a passive convention. So the P is voltage is 4 and current is 1.5. That means 6 watt. And this is a positive value. And this is a, what is that? This is a passive convention. So positive value means 6 watt is observed by VC, VS in this circuit. This is observed. This is another example. This is the problem. This problem is placed into a problem set in the last of this chapter. This ammeter is measured circuit is here. It is 5 amps following this way, and the voltmeter, the 10 volts. So determine the value of the R of this, the current controlled voltage source. So we need to define the problem. We need to make some simple the circuit. I will redraw the value, the circuit is more simple. This is here a Vs, the Vs here, plus minus the Vs, and then some resistor. So resistor, the value is R, and the current is IA, is determined by 5 ohms. 5. Then dependent source. So VB is RIA, and this way here, and the voltmeter shows the voltage between key point here and here is 10 volts. Then the question is, what is the value of R? Based on this voltmeter, now we know the VB is 10 volts. Then the characteristic of the voltage source, the VB is RIA, and RA was 5, so 5R. So 10 is equal to the 5R, so R is 2. This is 4 divided by this way. This is the gain of this current control, the voltage source. It's simple. Next the thing is the transducer. Transducer is the physical converter. I mean some physical quantities is to the electrical quantities. For example of that is potentiometer is a convert a potential value of resistor, and the temperature sensor is like convert the temperature values to the current, or the temperature value is different resistor. This kind of sensors. For example, can use this resistor here. What is the value of that? This is LP, this is the potentiometer, and they have some information here. This is a wiper. So based on the position of this wiper, LP is different. For example, we can make a electric circuit model. There's some source here. Then that value is 1 minus ARP and ARP. So the value is VM, is measurement value is dependent on the value of A. But A is determined by the position of wiper here. So based on this wiper's position, the value is varying, so the measurement value of VM is different. So based on that values, we can guess what is the position of this wiper. We call this device as a potentiometer. The temperature sensor is very similar. Some resistor has R values, but there's a function of temperature. Actually, resistor is dependent on the temperature values. I mean, in some material, when the temperature is higher, then R value is increasing, and temperature is lower, then R is decreasing. In the case of the Cooper, the resistor increasing the 4% of variation of 10 degree of temperature. That is very small variation of that, but in some material like a PB, including the 백금, the value is very the the resistor variation according to the temperature variation is very severe. So when you use some material, then you can measure the resistor values. By that, you can guess the temperature of the surround. I mean, in the environment around the material. That is a kind of a temperature sensor. These sensors, the physical quantity to the electric quantities, then you can say this is transducers. The last component we will cover in the circuit theory is the switch. This is a very important characteristic of that. Switch have two distinct states. This is open and closed, and act as a short circuit when it's closed, and acting as an open circuit when it is open. That means the switch has two states. It's open and closed. When you say open, that means between the resistor between two switch terminal is R is infinity. In this case, R is 0. So we can 0 in this way. This is switch. So two terminal here. Then we can draw in this way. T equal 0. That means initially open circuit, but the switch is closed. The switch is closed at T is 0. Then another thing is T is uniform to the direction of the arrow. This case in this way, that in this way. Then this is initially closed. I'm sorry. Initially closed. But this is open at T is 0. This is different type of the switches. I will give you some example of that. Very complicated the switches. So we can draw that is the circuit in simply without the switches, because the switch is the function of the time. We need to figure out what happened when at the time period. First, the time is 0 and 2 seconds is important. So we can draw if when T is 0 is smaller than 0, then we can draw the circuit again. Is 12 volts. And because this is initially open, so this is open, so open and 12 kiloohms, 8 kiloohms, 12 kiloohms, and initially this is a short. Is 10 kiloohms, 60 volts here, here 5 kilohm, and initially this is current in this point. So here, so this is open 4 kilohm in this way. This is a circuit when T is smaller than 0, and T is higher than 0 but small to 2. Then what happened? This is closed, so closed, and this is open. Here, then T is larger than 2, then this is open. I mean, actually this is moved from here to here, so That is second. So based on the time, because of these switches, we need to think a different circuit based on the switch status time. When this circuit can be written in this way, when time is similar to 0, so in period, this circuit can be represented by this way, and in period, this circuit can be represented by this in this way, based on the switch status. We can make some example about that. So what is the value of current? Time t is 4. Okay, mean we need to draw this circuit based on this time t. When time t is 4, then this switch is operate after 5 seconds, and this operates in 3 seconds. So because normally open, so at time 4 this is open, and this is open, and this will be open. So what happened? Then we'll draw this in here, 12 volts. Then this is not closed yet because this is defined in 5 seconds. And here, 3 kilo ohm. Then what happened? This is open. What time? It's 3 seconds. So at the 4 seconds, this is already open. So this is 60 volts. And here. So what's the value current here? I. There are no source current from this 3 kilo ohms. So I will be 0 ampere. This is another example. What's the value of the voltage V at time t4 and time t is 6? So we can draw this circuit in different time. At first, we think about t is 4 seconds. This is before, the 4 is before the 5, because this switch operated 5, and normally this switch is connected to this point. So we can draw the circuit is 2 milliamps and go connect here, and this is 3 kilo ohm, this is a V, and here. And what happened when t is 6? Then the switch operates in this way, so 2 milliamps, and it's going through this way, and register original current path connected to this source, because this is connecting this way. So value is here. So what is the value of that? Because the current flowing through this is, because this current source current flowing this way, 2 milliamps. So V is IR 2, that means 6 volts. But in this case, there are no current flowing this register. So V is IR is 0 volt here. So based on the status of the switching, the current is different. So this is a rough. Until this we cover what is the element in the electric circuit. That is a source, in the ideal source, ideal independent voltage source, independent current source, and dependent current source, dependent voltage source. And the switches determine the path as according to time. The switch can be modeled as a resistor. When switch is open, that means the resistor is very high values, infinity. When switch is closed, that means the resistor is 0, because there is no voltage difference between the switches. But that means the switch determines the current path, or the connection of the element.